Alright, so here we are with lesson number. Alright, so here we are with lesson number 2 for Unit 5. And this is where we really start to get into some of the math, but it's not trigonometry by any stretch of the imagination. It's just the basics, multiplying, dividing, adding, subtracting, and maybe some solving for x. So don't get crazy. So what exactly is gram formula mass? Well, you know, chemists, they want to feel really important. So we like to give at least five or six different names for the same thing. Well, this is a very good example of that. When you see the term gram formula mass or molar mass or molecular mass, even though they sound very different, they're pretty much the same thing. The only difference really is whether you're talking about something that's an ionic compound, a metal and a nonmetal, or something that's covalent, which means only nonmetals. So when we use the term formula mass, that really refers to an ionic compound. When we use the term molecular mass, that really refers to a covalent or molecular substance. So they're basically interchangeable. So you basically have 4 or 5 names for the same thing. Formula mass, gram formula mass, molecular mass, molar mass. They're all the mass of 1 mole, which we talked about in lesson 1. The mass of 1 mole of an element is the same as the atomic mass on the periodic table. So here's a couple of examples. If you look at the periodic table and look at the atomic mass of chlorine, and you really should have your periodic tables out. I know it's a pain in the neck, but please have it out. If I want to know the mass of 1 mole of chlorine, or its gram atomic mass, which is the mass of an element, well, all I do is look on the periodic table, look at the mass, and round it off to a whole number. So the mass for chlorine, the gram atomic mass, molar mass, formula mass, whatever you want to call it, is 35 grams. Okay? Now, sometimes you're going to see, when we've talked about these before, and we're going to learn more about these later on, but there are a couple of different terms that you're going to have to remember. One are called subscripts. And subscripts are basically these numbers that you see here in the formula. If there is no number, then of course there's a 1. So if you look at here, this is a ternary compound, right? So there's really a 1 here, we just don't write it. There's really a 1 here next to the nitrogen, and there's 3 next to the oxygen. Those are the subscripts, a 1, a 1, and a 3. Don't forget this subscript is a 2, and because it's outside the parentheses, that means you double everything inside the parentheses. Or in other words, multiply it by 2. And the subscript really tells you how many moles of ions are in each compound. So Al2O3, aluminum oxide, the compound has 2 moles of aluminum ions and 3 moles of oxygen ions for a total of 5 moles of ions. 2 aluminum moles and 3 oxygen moles. If you look at the one at the bottom, calcium, we know it has 1 mole of calcium atoms, right? And here's where the parentheses come into play. Everything inside is multiplied by 2, so we have 2 moles of nitrogen atoms, and how many? That's right, 6 moles of oxygen atoms. Okay, so let's do gram formula mass. Gram formula mass, as we said before, as opposed to gram atomic mass, they're still the same thing, is the mass of a compound, meaning if you take a compound and you add up all the masses of the elements in that compound, you would get the gram formula mass, molecular mass, molar mass. Okay? So again, you're going to need your periodic table. So the first thing you want to do is if I ask you to determine the formula mass, and really this would be molecular mass because that's covalent, this would be molecular mass also. This would be formula mass, and this would be formula mass because these two are ionic. But we're just going to use those terms interchangeably. And we'll call it, say, molar mass because you'll see that also. What you do is you have to dissect the compound and figure out, well, how many H's are in the compound and how many O's. Well, we already know from the previous slide that there's 2 moles of H atoms and 1 mole of oxygen atoms. So what I do is I take the 2 moles of hydrogen atoms and I'm going to multiply it by the mass of hydrogen from the periodic table. There's 1 mole, so and then I'm going to take the 1 oxygen mole and multiply it by the mass. So for example, this 2 is this number here. This is the mass of that element from the periodic table. The 1 that you see here is the subscript for oxygen that's not written times the mass of hydrogen from the periodic table. You basically multiply that together and you get 18 grams. Now the units for this are grams, and then you should put, and I'll see if I can draw this because I don't have a thing to draw with today. The units would be grams/mole. So you'd put a slash and then mole. So that means that water is 18 grams in a mole. So if I had 1 mole of water molecules, 6.02 times 10 to the 23rd, it would have a mass of approximately 18 grams. A half a mole would be 9 grams, 2 moles would be 36 grams, etc. I think you get the idea. So it's a good idea for you to maybe practice the next one, so you can pause the video and do it. This one's a fairly simple one. The subscript for C is 1, so that's 1 mole of carbon and 4 moles of hydrogen. So I have 1 mole of carbon, and that mole is 12 grams. I have 4 moles of hydrogen, and each of them is 1 gram. So 1 times 12 is 12, plus 4 times 1 is 4. So the formula mass, molar mass, molecular mass of this compound, methane, is 16 grams. So a mole of methane is 16 grams in mass. 2 moles is 32, half mole is 8, etc. Now these two are a little bit more tricky because not only are they ionic, but you can see that they're both ternary. So you should certainly practice these two. And be careful of the parentheses. Remember, the 3 means you triple everything inside the parentheses, but the 3 doesn't affect this. So you have 2 aluminums, and then you multiply everything inside by 3. So I'm going to go ahead and do this, but you can pause it. So the formula mass for this, and I called it its formula mass because it's ionic, but you could use any of the terms I mentioned, is 138 grams. Okay, the 2 here is this 2, and 39 is the mass of potassium from the periodic table. There's 1 carbon, and the mass of carbon is 12. And you have 3 oxygens, and the mass of each oxygen is 16. You multiply those together, and you get 138 grams per mole of potassium carbonate. The next one's aluminum sulfate, and the mass of that is approximately 342 grams. So let's quickly run through that. There's 2 aluminums, that's this 2, and the mass of aluminum from the table is 27. Triple everything inside, so I have 3 sulfurs, each sulfur is 32, and I have 12 oxygens, and each oxygen's 16. Multiply those numbers together, and I get 342 grams per mole. So the formula mass, gram formula mass, molar mass, etc., for aluminum sulfate is 342 grams. Okay, and that's how you do basically formula mass. And of course, any questions, please make sure to ask when you come in the next day, and we're certainly going to have plenty of practice problems, as you know.